So we're going to talk today about exponential function. Yesterday, if you watched the video, you should have been able to kind of have an idea of what an exponential function is and how it looks like. So just to recap, an exponential function is a function where your exponent is a letter. Okay? So your base is a number and the exponent is a letter. So we always, when this, for example, we know this is an exponential function because the exponent is the variable. Okay? Now, if you're looking at the graph of an exponential function, it's going to have a flat side and a side that's either growing fast or decreasing fast. So we see in this, for example, in this graph right here, we see a fast decrease, and then we see a slow decrease after that, right? So we're looking at fast on one side and then flat on the other side, okay? Which means it's slow. So for the generalization of an exponential relation is, so you have your y equals to, you have a base, and the base is a number to the power of a letter. Now this is the simplest form of exponential, okay? We're going to also look later on at an equation that looks like this with y equal an initial value a and then the base to the power of x. Okay, we're going to look at both equations because most of the time your initial value is not 1. What we are saying here that our initial value is 1, right? That's why we are just using this format. Okay, but this is the simple form, which is y equals b to the power of x. This is a little bit more advanced form where we have an initial value a that's other than 1. Okay, we'll talk about this a bit later. Now, if I'm going to look at my generalized exponential relation, which is y equal b to the power of x, b represents the growth or decay factor. Okay, so they're called growth. So it's either growing or decay factor. So in the example yesterday where the numbers were doubling, right? That means you were growing and the growth factor was 2, right? So that means your base was 2 and then your growth factor, it's called growth factor, it was 2, okay? When you had a piece of paper and then you were folding it twice. Now the question is, when will I have an exponential growth and when will I have an exponential decay? Okay? It all depends on the value of the base, okay, of your base b, that value of the base b. If b is greater than 1, then the relation is growing. And when b is between 0 and 1, then the relation is decaying. Okay, so let's look at the equation right here. So I have y equals 2 to the power of x. That 2 is a number greater than 1. That means my graph is growing. So if I look here, eyes on the board for a second, I always move from the left to the right. So if I look from the left to the right, I see that my graph is growing exponentially. Okay? Now if I look at the exponential decay, for example, if I look at my base, the base is 0.5. 0.5 is a number between 0 and 1, yes? So 0.1, 0.2, 0.3, 0.25. All these numbers that starts with a 0 point, they're a value between 0 and 1. So my base is between 0 and 1. And if I look at the graph, right, the graph from left to right, the graph is decreasing. right? Decrease fast at the beginning and then slows down as it gets closer, as the x value gets bigger. Okay? So this is called a decay. It's decreasing. Are we okay with that? So remember that the value of b in the case of growth, it's called the growth factor. And the value of b in the case of the decay, it's called a decay factor. Okay? So if my numbers are doubling, right, my growth factor is 2. If my numbers are being halved, then my decay factor is a half. Okay? So are you guys okay with this? All right. So the next question is asking you, what will the x-intercept be? All right. So to find the x-intercept, I need to let y equals to. So if I'm looking at an x-intercept, what would the y value be? What would the y value be? 0, right? So I let the y value to be 0. Okay? Why? Because any point, like if I'm looking at anything that's touching, this is right here, yeah? That point is -8, 0, for example. So the y value is 0. Anytime my graph is intersecting the x-axis, the y value is 0. Yes? Yeah. So let's look at the first example where we have y equals 2 to the power of x. So I'm setting y equal to 0, 2 to the power of x. Now how can I solve for x? Can I solve for x like this? No. So the only way I can solve for x is by doing guess and check. Okay? So if I want to do guess and check here, I'm going to have to plug in values for x. Okay? So give me value for x. Any value. So 2 to the power of 2, what do you get? 4. Is 0 equal to 4? No. So it doesn't work. Okay, give me another value for x.
0.
So what's 2 to the power of 0?
1.
So is 1 equal to 0? Doesn't work. Okay, give me another value.
Which makes 0 equals to 0?
Which makes 2 to the power of something. What is that something? So if I do 2 to the power of a number, and that's going to equal to 0. What is that number that's going to make it equal to 0? Let's try negative numbers. Give me a negative number that I'm going to plug in. So let's do y equals 2 to the power of -2. What's 2 to the power of -2? No? What's 2 to the power of -2? Quarter? 0.25? Try it. Yeah? So is that equal to 0? No. Let's try something even smaller. So 2 to the power of -10. Can you do that for me? What do you get? What did you get? What did you get? 2 to the power of negative 10. You're not putting the power. No. So you're going to do 2 power negative 10. So if I do 2 to the power of negative 10, that's going to be 0.00097. Again, it is not equal to 0. It's getting close to 0, but it's not equal to 0. And here's the case. Eyes on the board. No matter what number I put in, no matter how small negative number I put in, it's always going to give me 0.000000 and a number at the end. It's never going to reach that 0 at all. Okay? So this function right here, these functions, they will become flat. They will get close to the 0 line, but they will never reach that 0 line. So you're going to see this. So when you do the exponential function, you're going to see this. You're going to see a flat number where it's getting closer and closer to 0. It might look like it's touching it, but it's never going to touch it. It's going to be a number that's very, 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 very small, close to 0, but never going to be 0. Okay? So there's no x-intercepts. That's what the question is telling you here. Okay? So the answer for this, no x-intercept. Okay? You can even try 2 to the power of negative 20 if you want, right? Still, it's not going to give you an answer that is 0. Now, to find the y-intercept, what do I need to do? What's the value of x for the y-intercept? So if I look at the y-intercept here, right, for example, what is the value of x? 0. So to find the y-intercept, I plug 0 for x. Okay? So in this case, I have y equal 2 to the power of x. If I plug in 0 for x, so that would be y equal 2 to the power of 0. What's 2 to the power of 0? 1. So my y-intercept is 1. How about for y equals 0.5 to the power of x? Same thing, right? I do 0.5 to the power of 0. What's 0.5 to the power of 0? 1. Anything to the power of 0 is 1. Right? So unless I have transformation, okay, unless I have an initial value other than 1, your y-intercept is going to be 1. Okay? So whatever your initial value is, that will be your y-intercept. So in this case, my initial value is 1. Right? So that's going to be my y-intercept. Okay? Okay, so I have a table of value here, and then it's asking you to use the table of value to answer the questions below. All right? So the first thing that they ask you to do in the table of value, they ask you to find the first ratio. What's the first ratio? What do I do? It's not minus. It's called a ratio, not difference. Right? So instead of a minus, what do we do? Division. So it's y2 divided by y1. Okay? Anytime I want to know if it's exponential, I have to do the first ratio. Okay? So that's going to be 3 divided by 1. Yeah? So that's 3. 9 divided by 3. That's 3. 27 divided by 9. That's 3. 81 divided by 27. That's 3. So looking at my first ratio, what can you tell me? Is the relation exponential? Yes, because? It's asking to state the equation of the relationship. Remember that the equation of an exponential function, what's the general form? Y equals b to the power of x with my initial value. In this case, my initial value is 1, right? My initial value, that means that x equals to 0, yes? At x equals, so always, your initial value is at x equals 0. So what do I replace b with? B is replaced by your ratio. So that b value right here is the ratio that you get in your table, but when you're doing y2 divided by y1. So my equation is y equals, my initial value is 1, so I don't have to include it. It will be y equals 3 to the power of x. Do you guys get this? Is it going to be a growth or a decay? Growth, because the base is greater than 1. So if I want to graph this, I might not be able to graph everything. So this is how the graph looks like, but then if you want to extend it, To the left, it's going to be something like this, where it goes flat to the left. So the points, right? So you have your points, which is 0, 1, 1, 3, 2, 9. So 0, 1 is right here. 1, 3 is right here. 2, 9.